Okay, so here we're going to take our Sig Figs and go one step further. Okay, so last video we talked about counting significant figures, and that skill is going to be super important in being able to do this skill correctly. Okay, so we have our numbers, we make our measurements, now we have to do stuff with them. Okay, oftentimes in chemistry we do something in the lab, we get a value or a measurement, and then we have to manipulate it, or we have to do something with it to find our final answer. Okay, a lot of times that manipulation involves math, addition, subtraction, multiplication, division. Okay, so when we do those mathematical operations, we have to keep track of sig figs in order to keep our numbers right. Okay, so when we look at adding and subtracting with sig figs, maybe, here we go, we're going to add and subtract our numbers just like normal. Okay, so we're going to go take our calculator and we're going to do our operation, our addition or subtraction, just like we always would. Okay, we're going to, in our final answer, we are going to include the amount of decimal places that's the fewest in the original numbers. Okay, I know that sounds confusing, but it's going to make a lot more sense when we see an example. Okay, so your final answer is going to include the same amount of decimal places as the original number that has the least amount of decimal places. Okay, so here's an example. We're going to be adding these numbers together. I don't know why they didn't put the plus sign here, but we have 12.11, 18.0, and 1.013. If you were to add all these numbers up in the calculator, this would be your answer. This is what you would get. Okay? Our final answer, and the reason we have to account for these sig figs, is that our final answer cannot be more accurate than our least accurate measurement or our least accurate number. Okay, so we talked about accuracy in the notes last time, and we said that the more digits or the more decimal places we have, the more accurate a measurement is. So it's kind of like a chain is only as strong as its weakest link. A number is only as accurate as its least accurate constituent. Okay, so this number right here only has one decimal place. It's listed out to the 10th place. So that means that this number, my final answer here, has to be rounded to the 10th place. Okay, so I'm going to take 31.123 and round it to the 10th place. This 2 says that I keep this number at a 1, so my 31.1 would be my answer. Okay, that's the rule for addition and subtraction, is that you're looking at decimal places. Okay, when we get to multiplying and dividing, then we're looking at sig figs. So again, you're going to multiply and divide just like normal. You're going to take your final answer and you're going to make it contain the same number of sig figs as the number with the fewest sig figs originally. Okay, so let's look at an example. We have 4.56 times 1.4. You do this in the calculator and this is the number that you get. Okay, but again, our final answer can only be as accurate as our least accurate measurement originally. So of these two numbers, here I have 3 sig figs. There's 1, 2, 3. Here I have 2 sig figs. 1, 2. Here's the number with the fewest amount of sig figs with 2 sig figs. So I'm going to take my final answer and make it rounded to contain 2 sig figs. So there's 1 sig fig. I start my count from the left. So there's 1, there's 2. I'm going to round based on this number. So that rounds this number up to a 4. So I have 6.4. Okay? Here's some practice problems. And I know we only did 2 examples, but the rules are the same. Okay, so I'm going to put these 4 practice problems up. I want you to pause the video and do them. Take a calculator, do the problem. Remember that addition and subtraction, you're counting decimal places. Multiplication and division, you're counting sig figs. Okay, do these problems now. Okay, here's your answers. This number right here contains 2 decimal places. This number right here contains 4. So my final answer should contain 4. Before I show you the answer for number 2, or I guess letter B, this one's got 1 decimal place. This one has 3. So my final answer should contain 1 sig fig, or sorry, 1 decimal point. 1 number past the decimal. Okay. Here I've got multiplication. So I'm looking at sig figs, not necessarily decimals. All right, so here's 1, 2 sig figs. Here's 1, 2, 3, 4, 5. I'm going to keep the least amount. So I take 7.1 times 2.2654, take my answer, round it to the least amount of, or sorry, the least number of sig figs, so 2. And so now I have 16 decimeters squared. Here I'm dividing. So again, I'm counting sig figs. This number has 3. This number's got a lot more than 3. So it has 6 sig figs. I need to keep my final answer to 3 sig figs. And so these zeros don't count. Those are my leading zeros. 1, 2, 3 sig figs. Okay. These mathematical operations and the ability to do them with sig figs is very important. Okay. Let's look at rounding. Okay. Obviously, these rules for rounding are always going to be the same. You've learned how to round since like probably 3rd or 4th grade. Okay. But counting sig figs is a little bit different. Okay. So you're going to round each of these numbers to the number of digits or the number of significant figures in parentheses. So let's say I have this number, and I think I'm just going to pop these up here for you. I got this number, and I need to round it to 3 sig figs. I'm going to start my count from the left, and I'm going to count my sig figs. There's 1, 2, 3. I'm stopping at 3. I'm going to round based on this one. This tells me that I need to not round it up because it's less than 5. So this number becomes 101, and then everything after it just changes into a 0. And this becomes centimeters. Okay, so now if I were to look just at this number right here and count my sig figs, there's 1, 2, 3, and then trailing zeros don't count if there's no decimal point, and there's not. So those numbers are not significant. Okay, let's do this one. 2, 5, 3, 4 rounded to 2 significant figures. There's 1, there's 2. This number is less than 5. So this becomes 2, 5, 0, 0 kilograms. Let's look at this one. We've got 3 sig figs. 1, 2, 3. Round based off of that one. That number's above 5, so this number, my 2, is going to get bumped up 56.3 seconds. Everything else after the decimal point, since this is after a decimal, all of this just drops off. Okay, and it goes away. 145 Kelvin to 2 significant figures. There's 1, there's 2. Round off of that one. So this becomes 150. 145 rounds up to 150. Okay. If you were to just leave this one as 15, that would not be right. Okay? You have to make sure that that 0 stays in as a placeholder so that you can, so that, 145 obviously does not round to 15. 145 rounds to 150 pretty easily. Okay? I know that's real quick. That's what our in-person time is for. If you've got questions or need more clarification, find me in class. Ask me in class. Okay? It's really important that you understand significant figures as we move forward into making measurements and doing labs and performing calculations the right way. Okay? All right.